Hi, thank you for watching this video. This is finding the GCF. GCF is the greatest common factor, and this is also called factoring. So I want to go through these examples. I had recorded this video before, but it was too long to upload, so I'm just going to kind of just go through these, okay? Due to time limits, it was just too long, so I'm going to kind of just go through them. So we have a binomial. We have x squared plus x. So I'm going to go ahead, when I'm finding my GCF, is set up my ladder. This ladder to me symbolizes division. So I'm thinking, what do these two have in common? I have an x here and an x here. So they both have an x. So I'm going to pull out an x. So this one has an x squared, and this one has an exponent of just that imaginary 1. So that's why we're only pulling out the smallest number. Even though it's the greatest common factor, it's still the smallest one of the bunch, okay, of these two. So if we're dividing, and we know we are pulling out the x because they both have them so both have it in common. We know x squared divided by x, or x squared divided by x, and we can put in that imaginary 1. And we know with exponents we are subtracting. It would be x to the 2 minus 1 would be to the first power. So we can go ahead and just put our x here because we don't need that imaginary 1. If you can put it in if you want. Okay. Now we know we have a plus, so we're going to go ahead and say plus x divided by x. And if we went over here and did x divided by x, x divided by x is 1. Anything divided by itself equals 1. So we're going to go ahead and put that 1 in here. So to write this as your final answer, we take this number out here and we write x times, and we take this piece right here and we write x plus 1. And that is your answer. Let's look at a second example. So we have here t to the 5th plus, and actually I want to change this one to t to the 3rd. Okay, t to the 3rd. So t to the 5th plus t to the 3rd. Let's go ahead and set up our ladder, and let's think division, right? And what they have in common. They both have a t. So let's go ahead and pull out that t. And we see that they both have exponents. Which one has the smallest exponent? 5 or 3? This 3 is the smallest one, so we're going to take out the 3. Okay? So what we're going to do here is we are going to divide. T to the 5th divided by t to the 3rd. So t to the 5th divided by t to the 3rd equals, and we know if we're dividing, we're going to be subtracting our exponent, so that would be t to the 5 minus 3 is t squared. So we're going to write t squared plus, and let's write t to the 3rd divided by t to the 3rd. And anything divided by itself, t to the 3rd divided by t to the 3rd is 1. So t to the 3rd divided by t to the 3rd is 1. Okay? So essentially I'm pulling things out. Okay? So I'm going to write our final answer. We take the piece that we pulled out and we put that on the outside of our parentheses, t to the 3rd times, and whatever it is right here, t squared plus 1. And that is our final answer here. Let's go ahead and look at another example. So we have here x squared plus x. So let's go ahead and set up our ladder. Okay? Now, Do we have any matching coefficients or anything that can be divisible between 7 and our imaginary 1? No. So we're going to leave it. We're going to leave this 7. What else do they have in common? They have an x here and an x here. So we're going to go ahead and just pull out our x. We're leaving the 7. We're not messing with the 7 at all because there's nothing to pull out, okay? So we're pulling out our x. This one is an x squared, and we have x here, and that could be to our imaginary 1. So we're just going to keep it at our smallest one. And we're pulling out this one here. Essentially, we're pulling out this one. And we can put our imaginary 1 if you'd like. So let's go ahead and start dividing. So we're not doing anything to our 7, so let's go ahead and pull our 7 down. X squared divided by x squared divided by x equals, and we're subtracting our exponents, x to the first, or we can just write x plus x divided by x divided by x equals 1. So we're going to write 1 here. So our final answer, we take this piece on the outside and write x times this whole piece down here, 7x plus 1. And that's how we write our final answer for this one. Let's look at another example. So we have 2y plus 12x. 2y plus 12x. Okay, what do we have in common? We have a 2 here and we have a 12 here. Think division, okay? What number can divide evenly with 2 and divide evenly with 12? It's 2. Because 2 divided by 2 is 1. 12 divided by 2 is 6. Now, this one has a y and this one has an x, okay? They're not the same. We can't pull that out because they don't share, each term doesn't share them. So let's just leave it at 2. So 2 divided by 2 is 1. We didn't do anything to our y, so we're going to leave our y. Plus 12 divided by 2 is 6. And we didn't do anything to our x because they're not the same. So we're going to say, we're going to leave our x here. So our y is here and our x comes down here. So let's go ahead and write our final answer. We're going to put our 2 out on the side and then our parentheses, everything right here. 2 times 1y plus 6x. All right, let's look at another example. And I'm going to fix this. So we have 9x plus 45y. So let's think division. What can we pull out here? Let's look at our coefficients. We have a 9 and we have a 45. What number can divide evenly between 9 and 45? It would be 9. So 9, and then because 9 divided by 9 is 1, and 45 divided by 9 is 5. Now let's go ahead and look at our variables that are attached to it. We have an x here, but we have nothing here. So we still can't pull that out. So we're going to leave them. 9 divided by 9 is 1, and we're going to pull down our x, plus 45 divided by 9 is going to be 5. So let's write our final answer. Make sure that you pull this 9 out in front, 9 times, and whatever's right here, 1x plus 5. I think I have time for one more example. So I'm going to do this one. We're going to do 3xy minus 12y. Okay? So let's go ahead and look at this one. Let's go ahead and set up our ladder. Okay, so looking at our coefficients, we have a 3 and we have a negative 12. What number can go into 3 and 12? The smallest number that can go into both of them. It'll be the greatest common factor, but it would have to be smaller than 12. It would be 3. Okay, because 3 divided by 3 is 1. Negative 12 divided by 3 is going to be negative 4. So that would work. Now let's look at our variables attached to it. We have an x here, but we don't have an x here, so we have to leave it. But I do see we have a y here, and we have a y here. So we can go ahead and pull out that y. So let's go ahead. 3 divided by 3 is 1. We're not doing anything to our x. We haven't pulled anything out, so we're going to leave our x. Y divided by y cancels out. So we're essentially pulling out that y, so we don't have to write anything. Negative 12 divided by 3 is negative 4. And y divided by y is just, they cancel each other out, so you don't have to write anything. So let's go ahead and write our final answer. I'm going to take this number out here and write 3y times, and whatever's right here, 1x minus 4. And that is your final answer.